In this video, I'm going to talk about how to use a table to compute probabilities and to map out to draw a picture of the sample space. And with tables, they're similar to tree diagrams in a sense that they use a visual to show the sample space, but the only downside with a table is that it only works when you have an experiment with exactly two outcomes in a sequence. So for example, like example 1, we toss a coin and then we roll a die. Maybe two puppies are born, so puppy 1 and puppy 2, or maybe we roll two dice. This wouldn't work if we were going to toss a coin and then roll a die and then toss another coin, so to have more than two. So let's look at this first example where we toss a coin and then a die is rolled. And I'm going to show you how you can use a table. So all you need to do on one side of the table is illustrate the number of all of the outcomes for the coin toss. So I'm going to put those vertically here. And so the coin toss, we can either get a heads or we can get a tails. And then for the die, we could either get a 1, a 2, a 3, a 4, a 5, and a 6. And I could have put the outcomes for rolling a die on the vertical side. I could have flipped these around and that would have been okay too. So then all we have to do is we combine them. So like the H and the 1 together, and I write a heads and then a 1. And H and 2 come together, and so I write all of the different outcomes together in a table. And so tails and 1, we bring those together. Tails and 2, tails and 3, tail and a 4, a tail and a 5, and a tail and a 6. So the sample space is all of this. So we can easily count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 different possibilities. So you can see this is very easy to see, just like a tree diagram. And now we can use this to ask, find some probabilities. So this question asks us to find the probability of getting a heads on the coin and a number less than 5. So probability of heads and a number less than 5. So notice we have the word and, so both have to be true in order for me to count it. So I'm going to look for any outcome where I see an H and a number less than 5. So like an H and a 1, an H and a 2, H and a 3, and H and a 4. I'm not circling H and 5 because less than 5 means not including 5. So now I'm just going to count those. So there's 4 outcomes that represent that situation of heads and less than 5 out of 12 total. So my probability is 4/12, or if I reduce by dividing both by 4, I get 1/3. Now let's look at example 2. So this example, we're going to consider an experiment that involves tossing a die twice. So the table is perfect for this because there are 2 different events happening one after another, and I've got all of the sample space for rolling a die, the first die and then the second die. So you can consider one of these, so the vertical, you could consider that die 1, and then up here the horizontal die 2, or the other way around, it doesn't matter. And so what I'm going to do is I'm going to fill out this table just listing out all the combinations. So I could get a 1 and a 1 on the die. I could get a 1 and then a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Or I could get a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. Or a 3 and a 1, a 3 and a 2, a 3 and a 3, a 3 and a 4, a 3 and a 5, a 3 and a 6. Or a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4, 4 and a 5, 4 and a 6, or a 5 first and then a 1, a 5 and then a 2, a 5 and then a 3, a 5 and then a 4, a 5 and then a 5, a 5 and then a 6. And lastly, I could get a 6 first and then a 1 next, a 6 and then a 2, a 6 and a 3, a 6 and a 6. I meant 4. Getting ahead of myself. A 6 and a 5 and a 6 and a 6. And so there are 36 possible outcomes here. for rolling 2 die. And these problems come up pretty frequently. This is a chart that you might want to keep handy because the questions themselves aren't too bad as long as you have this chart. It's really much more difficult to answer these questions when you don't have the diagram of the chart. So let's figure out the probability that you roll a sum of 8. So sum means adding the two numbers on the die together. So all of these are going to be out of 36. And in terms of sum, it might even be helpful, maybe in a different color, to go through and jot down the sum. So like 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. And I could write down the sums. 1 plus 2 is 3. And the nice thing is they actually end up going in order. So it makes it really easy to fill this in. 1 plus 4 is 5, 2 plus 4 is 6, 7, 8, 9, 10. So all these red numbers are just the sums. And if this is too busy, then you don't have to write these out. You could just think about the sums just when you're asked about them in specific problems. And so now we can easily look, okay, so out of the 36 possible outcomes, how many give you a sum of 8? Well, we can look at the ones that just say the 8. So there's 1, and let me use a different color. So we could use 1, 2, 3, 4, 5. So it looks like there are 5 outcomes that give us a sum of 8. So there's a 5 out of 36 chance that we're going to roll a sum of 8. For the next one, we're looking for doubles. So that would be like a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, or a 6 and a 6. So all of these different options. So 1, 2, 3, 4, 5, 6. It looks like we have 6 outcomes that give us a double, and we could reduce that by dividing those both by 6, and we get 1 6. And then remember, if you've got a TI 34 or 30, you can use the fraction button and just plug in 6 over 36 and then use the simplify key. And keep hitting simplify until you can't hit it anymore. Well, you can still hit it, but keep hitting it until you see a factor of 1 where you're not getting a new fraction. So it means that it's reduced to lowest terms. And then the option on the graphing calculator would be to just divide those. So 6 divided by 36. And then hit, so that's the decimal answer, and then math, enter, enter, and that gives us 1 6. The last one, so what's the probability that we get a sum less than 5? So that's not including 5. So that would be a sum of 2, 3, or 4. So we're looking at, let's see, these and these. So 2, 3, or 4, and it looks like all of the other sums are 5 or greater. So if we count 1, 2, 3, 4, 5, 6, it looks like there are 6 different options that give us a sum less than 5. And so that's the same answer as before. That reduces to 1 6. And so that's the probability of getting a sum less than 6 or sum less than 5 when rolling 2 die.